So let's go through the integral of 28th May 2026. This is the hard difficulty. Let's go. So here I've isolated the integral and split up the square root to both the numerator and the denominator. So we see that the integral is from 0 to infinity, and we see the floor function. Now when we see the floor function, let's ask ourselves a few questions. So first, what values can the function inside take? So what values can the function have over the interval, so from 0 to infinity, and at what points will the function jump to the next point, so let's say from 0 to 1. And we must also remember to integrate this function piecewise, because the floor function is discontinuous and it takes the various integer values. So let's see, what values can the function inside take? Let's answer that first. So to answer that, maybe you can look at the maximum of the value to see what is the maximum value that the floor function can take. So this can be easily determined by just simply taking the derivative and equating it to 0. So solving for this, we have this equation right here. So if we solve for that, it should give us a simple quadratic, which should give us x equals to plus minus 1. We reject the minus 1 because we have the square root here, and we can't have complex numbers here since it is over a real interval. So let's reject the -1 solution and simply have the +1 solution here. If we plug in x equals to 1, we see that the function will be equal to square root of 10, and the floor of square root of 10 will be 3. So that is the maximum value that the floor function can take. So it can go from 0, 1, 2, or 3. Now it is not in any of the negative values because it can't be negative since you have two square roots here and the constant square root of 20 is positive. So that means it cannot be negative in any way. So the minimum is 0, and this can definitely be proven by just plugging in x equals to 0. Yeah. Now we wish to answer the second question. What points will the function jump to the next value? So let's say from 0 to 1, 1 to 2, or 2 to 3. To solve for that, let's just simply equate the function inside to the numbers outside. So let these four numbers, like one of them just be n. So we want to find the value of x of n, which would determine the value at which the function will be equal to that n. Yeah, okay, so we have this basically. So let's say you want to find for n equals to 1, x of 1 will be equal to something something. Yeah, now let's solve for that. Okay, we have this equation. Simplify this. It is trivial to see that x of 0 will definitely be 0 because you can just plug in 0. Yeah, but n cannot be 0 over here if you're using this method, since you're multiplying both sides by yeah by 0 basically. Yeah, so we have this quadratic right here. Now let's find the general form of x of n, which should be this. Now plugging in the different values that we have, 0, not 0, 1, 2, and 3, should give us these values right here. Yeah, okay. Now we see the plus minus sign over here, so that probably means that the function will go back down to, let's say 2 from 3 after it passes the 10 plus square root of 19 over 9 point. Yeah, it will go back down to 2 probably. Since we already know that the function at infinity equals to 0, so that probably means at some point the function will go back to 0, and the function will be decreasing after the maximum point. Yeah, so that's what we are theorizing over here. So you know what? Let's let the we can choose either the plus or minus sign for the function, for the equation to hold true, right? So let this be denote that the negative sign is chosen, and let this denote that the positive sign is chosen. So now we have these range of values over here. Yeah, you can read this for yourself. Pause here to read if you want. Okay, now that we have these values, we just simply have to solve for the length of the segment. So let's say from x1 minus to 0, the function is equal to 0. So that basically means that the area under the straight line is 0, basically. Yeah, since the height is 0, then the area will be 0. Now, let's look at this. F of x is equal to 1, so that means the height of the straight line is 1, and the length will simply be x2 minus x1 minus. Yeah, and so on and so forth for the remaining values. This will be the height, and this will be the length. So multiply this by this will give you the area under the curve, which is the integral. Now, let's go back to our integral over here, and let's plug in our values. So we have this equation over here, which can simplify to become this. Now, if we go back to our square roots, the integer, actually no, the rational part will cancel out, and the irrational square root part will simply double. So we have this over here, and if we simplify this, we should get this final answer. Yeah, so this is our answer. Thanks for watching.